Hi guys, welcome to Chakravyuh Science Academy, just a minute series where every minute counts in locking the secrets to master your board examination. Today we have come up with a very important paragraph based questions, hot questions. It is a very common problem for most of the students in organic chemistry where they'll give you a paragraph with some hints and they'll ask you identify A, B, C, D, E or X, Y, Z, whatever. Okay. Remember these type of questions are sure shot going to be there in the board examination. So today I'm going to tell you how to approach this type of questions. So stay tuned to the end, okay? Because you are going to gain a lot of things from this video. So first of all, let's approach the first question. So first question is saying compound A with molecular formula C4H9Br. So let's write it down, whatever the data is provided in the question. So first it says there is a compound A and it says its formula is C4H9Br. One thing is clear, by looking at it, we can say it's an alkyl halide. Now, second thing, it says it is treated with aqueous KOH. So when you are treating it with aqueous KOH, now we know when aqueous KOH is used on the alkyl halides, it is a nucleophilic substitution reaction. Now let's read the question more. It says the rate of this reaction is depend on concentration of compound A only. It means it says the rate of this reaction is only dependent on concentration of alkyl halide. So one thing is certain, it is unimolecular. So we know this reaction is certainly going to be the SN1 reaction, okay? SN1, because rate of reaction is only dependent on concentration of alkyl halide. Now let's read more. Then it says another optically active isomer. So that means it says whatever is B is optically active. Now, how can the compound be optically active? It should must have a chiral center. It should must have a chiral center. What is a chiral center? It is the asymmetrical carbon where its all four valency needs to be different. Okay. Now it says when it is treated with aqueous KOH. So what we saw, the rate of reaction was dependent on the concentration of alkyl halide as well as on KOH, which is a nucleophile. It means here the rate of reaction is dependent on both the concentration of nucleophile as well as the concentration of alkyl halide. So one thing is there, it is SN2. So now let's try to identify the compound isomer A and B both from the given hints. Okay. So C4H9Br. So we know SN1, who gives the fastest SN1? 3-degree alkyl halide. So we will take 3-degree alkyl halide here. So let's try to make tertiary butyl bromide. So this has to be our isomer A. You can see that it has 4 carbons and 9 hydrogen with a Br. So this is our isomer A. 3-degree, why we have taken 3-degree, why we have not taken N-butyl bromide? Because it's SN1 reaction. Now what we can take here, now we have two options. Because it is SN2, SN2 is steric hindrance. So that means 1 degree and 2 degree gives it, 3 degree will not give. But the condition is we can take N-butyl bromide, but in N-butyl bromide, in 1 degree alkyl halide, we will not find the optically active chiral center. So let's try to make 2 degree. So where we make 2 degree, so you can see this carbon has a hydrogen, it also has a methyl group and it has a bromine. So you can see this carbon is the chiral, it has all four valencies different. Here it is methyl, here it is ethyl, here it is bromine, here it is hydrogen. So all four valencies are different. This carbon is a chiral carbon. So definitely this will be the isomer B and this is our isomer A. Now, what more? They are asking you to draw the structural formula. So we already obtained it. Now the question is telling you out of the two compounds, which will give you only inversion. So we know in SN1, we get both retention and inversion. We get retention also, we get inversion also both. Okay. And when they both are formed in equal amount, we call it as, what do we call it? Racemic mixture. Okay. But in SN2, we know we only get inversion. Only inversion products are formed. Only inversion is formed. So that is why for the second question, answer will be isomer B. Now let's see the next question. Okay. So in the next question, we can see it says organic compound A. So let's write it down again. So organic compound A, okay, on heating with ammonia. So you are heating it with ammonia. Now it says also you are heating it with cuprous oxide Cu2O at a very high pressure. Okay. Now it says it gives you compound B. It's okay. Now it says B may, what you are doing is you are treating it with NaNO2 and HCl, which we know NaNO2 plus HCl. We know where it is going. It forms nitrous acid. Okay, freshly prepared nitrous acid at ice cold means 0 degrees Celsius. So it forms C. Now it says C on which heating with copper and HCl. So it gives back the A. So it means if you heat the C with Cu plus HCl, it will form UA. So we know what reacts with HNO2 nitrous acid, okay, at cold condition to form C. What do we get? It's a diazotization reaction. Guys, please see this. This reaction is a diazotization. It's a diazotization reaction. So we can write it now that B definitely will be. So let's write it here. So B has to be a aniline. Now when you do the diazotization reaction, so this is B, so it will give you diazonium salt. So N2 plus Cl minus. Now understand in diazonium salt, when you add Cu and HCl, it gives you, when you add Cu and HCl, so we know it will give us a chlorobenzene. And because it says this is the A substance, so one thing was sure that when we heated the chlorobenzene with ammonia and cuprous oxide at high pressure, we got aniline. So in that way, you learnt a conversion also, how to what is diazotization reaction from aniline to benzene diazonium salt, and what happens in the diazonium salt when we add copper and HCl, it forms chlorobenzene. Now what happens, how to convert chlorobenzene to aniline by using heating with ammonia in the presence of cuprous oxide. So this is our second question. Now let's see the next one. All right, guys. So let's see the next question. What it says: a primary alkyl halide. Now focus on the word primary alkyl halide. It means we have just done this question in the first case. So C4H9Br. So it has to be a N-butyl bromide. It has to be a N-butyl bromide. So let's write the structure of N-butyl bromide here. Okay. So we will write it here: CH3, CH2, CH2Br. No, one more CH2 will come up here. So and butyl bromide, because it says primary alkyl halide 1 degree, okay, 1 degree alkyl halide. Now this is our substance A. Now it says it reacts with alcoholic KOH to give compound B. So let's do it. Let's add alcoholic KOH. Now you know aqueous KOH gives nucleophilic substitution reaction on haloalkanes, but when you use alcoholic KOH, it will carry out dehydrohalogenation, alpha beta elimination. So the carbon which contains the halogen is alpha and the neighbor one is beta. So dehydrohalogenation. So what will be the next compound? So it will be CH3, CH2. Now from here you'll remove one hydrogen, so it will be CH, double bond, and it will be CH2. So we got, as a result of dehydrohalogenation, we got our substance B, alkene. Now it says you add HBr, it gives C. So let's add HBr on this. So remember, when HBr and peroxide are together, then it is anti-Markovnikov. But only HBr, it means it will be a Markovnikov rule. So we will add Markovnikov's rule, okay? We will be doing Markovnikov's rule. It means the carbon which has less hydrogen will get the negative part. So in H plus and Br minus, so the negative will come on the carbon which has less hydrogen. Positive will go to the carbon which has more hydrogen. Okay. So what is our product C? So it will be CH3. You can see that CH3, then CH2, and then C H, which will get the Br because it has less hydrogen, and the CH2 becomes CH3 because it has got the positive part, because it has a more hydrogen. Okay. Now this is our compound C. Now the question says the C is the isomer of A. We can see that this is a 2 degree alkyl, this is 1 degree, both are C4H9Br. So they both are the isomeric form. Now the question is saying that when A is reacting with sodium metal, we know what it is, sodium metal. That is, whenever they say, it means it is a Woods reaction. So let's try that as well. So take the A substance, CH3, CH2, CH2, CH2Br. Now react this with the sodium. So for sodium, we'll take 2Na and one more of this substance. So it is Br, CH2, 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 CH3. So what is going to happen, guys? So what we will do, this Na will remove, take out the Br, Remember, don't forget to write the ether, which will be a solvent. Okay, and finally, this 4 carbon and this 4 carbon will join to form octane. So we know what is the formula of octane? C8H18. So this is our substance compound D. After carrying Wood's reaction on the compound A, we got the D as per the question, which is also says it is C8H18. You can verify that. 4 and 4, 8. Okay. Now it says which is different from the compound form when N-butyl bromide is reacted with sodium. That's correct. And they're asking give the structural formula of A and write the equation. So you can see answer is right in front of you. So do approach this type of question from the information given and then one by one use the reagent, use the mechanism into writing the answer. It will become very easy when you have the practice of such type of questions. And remember, these questions are sure shot going to be there in the board exam. So now I am going to give you one question. You all have to try as a homework and don't forget to give the answer in the comment box below. So let's see the next one. So this is the homework question. You can see here it says alkene with molecular formula C5H10. So write down the hints what's given. On ozonolysis means O3 ozone and followed by zinc and H2O, which will form either the aldehyde or a ketone. So let's read the question more. So it says it gives a mixture of two compounds B and C. Compound B gives positive Fehling's test and also reacts with iodine and NaOH solution. It means it will not only give the Fehling's test, but it also gives iodoform test. For iodoform, we know it has to be a alpha methyl ketone. Now after that, what it says, compound C does not give Fehling test, but gives iodoform. It means it will not give Fehling's. You know that the ketones don't give the Fehling's test, right? But it is giving you iodoform. So be careful on that. And it says identify compound A, B, and C. So you need to formulate and draw up the structure of C5H10. Must be alkene because alkenes only can undergo ozonolysis. You all know that. So do this question as a homework and please do write the comments, okay, as IUPAC naming, as it motivates us to make such more videos. And don't forget to share with your friends who may need it. So bye bye for now.